Hey guys, welcome to the notes for adding polynomials. Our essential question is, what is a polynomial and what are like terms? So we kind of went over what a like term is, but these are terms that have the same variables and exponents. Okay, so like example of like terms would be 15x and 3x, or 15y and 5y, or negative 2x and 3x. So those are all like terms. All right, so these are some new words we have down here, which is monomial, binomial, trinomial, and polynomial. So if you look at these three here, we have mono, bi, and tri. So mono means one, bi means two, and tri means three, just like a bicycle or a tricycle. So a monomial is going to be one term. Okay, and then a binomial would be two terms, and a trinomial is three terms. And I'm going to give you some examples of what those are. So an example of a monomial would be like 5, or 3x, or 7y squared. So these are all one term because they're just one grouping. Our next example is going to be for a binomial. So something like that would be like 5x minus 7, or 3 plus 2x squared. These are binomials because they're two terms. Okay, so they're two different terms. And remember, terms are separated with minus and plus signs. So the first ones up here were monomials because they were just by themselves. And then these, there's two of them because they're being separated by a plus or minus. A trinomial is three terms, so that's going to maybe be 5 minus 2x squared plus 7x. So that's three terms right there, which is a trinomial. All right, a polynomial is a little bit, it's an umbrella term. So I could say it's an umbrella term, which means it covers all of those, which means it's one or more terms. And if it's one or more terms, it's considered a polynomial. So all the three above that we had are all polynomials. We just have special names for them. So if it's only one term, you call it a monomial. But it's technically also a polynomial. But you want to be more specific. So if you can be specific, be specific. All right, the standard form of a polynomial. So the standard form is going to be the order of terms from the greatest exponent to the smallest exponent. Okay, and we'll talk about what that means in a little bit, so go ahead and write that down if you haven't. So let's talk about what that means. What does that mean for us? Well, let's write an example down. All right, so I have an example here. I have 7x minus 5 plus 3x to the 7th minus 2x to the 5th. So this is my example. Okay, now the standard form of a polynomial is the ordering of, or the order of it from having the greatest exponent to the least exponent. So the greatest exponent here, which is our largest exponent, is going to be the 7 right here because it's the largest exponent. The exponent on the first term is technically 1. This one's 7 and this one's 5. And if you're wondering what the exponent is for this term, it's actually technically x to the 0 because there isn't an x. So the first term is going to be first, which is 3x to the 7th. And then you're going to list it from the next largest, which is going to be the 5. So we're going to have minus 2x to the 5th. And then we have plus 7x. And the reason why it's a plus is because the 7x is positive. And then we have minus 5. So that's the reordering of it. We reorder from greatest to the smallest. The degree of the polynomial is, or the degree of the polynomial is the greatest exponent in the polynomial. So, using the last one as an example, if we have 3x to the 7th minus 2x to the 5th plus 7x minus 5, right, this is in standard form. If we use the last one as an example, the degree of this one would be a 7th degree polynomial. Okay, so that's a 7th degree because the highest exponent that you see is a 7. Whereas, like maybe this one, this is a 2nd degree because your highest exponent is a 2. That would be a 2nd degree trinomial because of the 3 terms. All right, so let's move into some examples and practice this. For the following expressions, determine the degree and classify the polynomial. Then put it in standard form. Okay, let's go ahead and classify. What's the largest exponent that we see in number 1? Well, the largest exponent that I see is 5. So this is going to be a 5th degree. And then what type of polynomial is this? Well, there's 3 terms, so this is going to be a 5th degree trinomial. And now we're going to reorder this in standard form. So you're going to start with the one with the largest exponent first, which is x to the 5th. And then you have 3x to the 3rd. And then you have the positive 7. Okay, moving on to number 2, we have 8x minus 5x squared. Again, you're going to look for your largest exponent. That's going to be the 2, so that's going to give you my degree, or give us the degree, 2nd degree. And since there are only 2 terms, this is a binomial. So a 2nd degree binomial. We're going to reorder this. So we're going to start with our highest degree, which is going to be the negative 5x squared. So make sure you bring the sign in front of it. And then we have plus 8x. Only 2 terms there. All right, number 3, our largest degree here is what? The 7. So it's going to be a 7th degree. And since it's larger than 1, 2, or 3 terms, it's going to be just a polynomial. So there's no special name for this one. And we're going to start with our largest, which is 3x to the 7th. Then we're going to go to the next one, which is going to be 4x to the 5th. The next is negative 8x to the 3rd plus 7x minus 2. And if it helps, if you want to, well, if it helps, you can go ahead and cross out the ones that you've used, right? So if that helps you narrow down which ones you've used, go ahead and do that. So this would be our standard form for this polynomial here. All right, so for adding polynomials, we're going to have 6 examples, I believe. 1, 2, 3, 4, 5, 6 examples. And there's really only 2 steps to adding polynomials. So the first thing you always want to do is you're going to first distribute. Okay, the next thing you're going to do is you're going to start with the highest power. And we'll talk about that. And actually, I'm even going to change it and say highest exponent so that we know exactly. So exponent and power are sort of the same thing. Right, so instead of saying x squared, I can say x to the power of 2. All right, so let's go ahead and start with number 1. Number 1, I have 5x squared minus 7 plus 2x squared plus 5. So I have 2 sets of, I have 2 binomials here, and I'm adding them. Okay, well, normally when I see parentheses, I want to distribute. But what's the number in front of this technically? It's technically a 1, and there's technically a positive 1 over there as well. Well, 1 times anything is just going to be itself, right? It doesn't change anything. That means, let's go, erase. Okay, that means I can just drop my parentheses, and I have 5x squared minus 7 plus 2x squared plus 5. Because when I distribute a 1, it doesn't change. That was my first step, was to distribute, and I did that. It didn't change anything. Okay, the next step is to start with the highest exponent. So you always want to combine like terms. And remember, like terms are the things that have the same variable and exponent. So I'm going to combine like terms. So here, my like terms are 5x squared and positive 2x squared. These have the same variable and exponent. And you always want to start with the highest one. So here would be the 2. All right, so this would create 7x squared. And then I also have like terms here with negative 7 and positive 5, and that gives me negative 2. All right, so that would be our answer there. And what would this be? This would be what type of polynomial? This would be a second degree binomial because the highest exponent is a 2 and there's only 2 terms, which makes it a binomial. So moving on to the next page with number 2. All right, we have 3x cubed minus 5x squared plus 2 plus 7 minus 4x squared plus 7x cubed. So this looks like a lot more, but really, it's just more terms. Not really much more math that we have to do. So again, the first step is to distribute, but again, I only have a 1 and it doesn't change anything, so I'm going to go ahead and copy down everything I see. And if you're using pencil, then you can probably just erase your parentheses, but I do want you to see this step on my screen, so it won't bother me if you decide to erase those. So I can drop my parentheses because 1 times any of that is still going to be whatever that was. Then I'm going to start with the highest exponent that I see, and the highest exponent that I see is the 3. It's the positive 3 up in the exponent. So 3 is the largest exponent, and I'm going to start with that one. And the reason I start with that one is because I'm trying to put it in standard form and I don't have to do it later. So 3x cubed plus 7x cubed is 10x cubed. Okay. Moving on. What's our next highest exponent? A 2. Well, that's going to be negative 5x squared minus 4x squared. That's going to be negative 9x squared. What color should I do? Let's do baby blue. Okay, now I have 2 plus 7, and that's going to give me positive 9. So this would be my final expression here. I've combined all of my like terms. And if I wanted to check how, whoa, my iPad's frozen. If I wanted to check that they were all combined, you can always check at the very end and be like, do I have any like terms at the end? And then that could be your final check. Now let's classify this. Well, this was a third degree because the highest exponent is a 3, and this would be a trinomial because it has 3 terms. All right, moving on to number 3. We have 2 times x squared minus 4 plus 3x minus 5x squared plus 37. Now let me ask you this. Can I just drop the parentheses here like I have been doing? Nope. I actually have to distribute here. So there is a 2 on the outside, and that does change my answer. However, on this one, it's just a 1, so those can drop. But the first set of parentheses have to be distributed. So I'm going to distribute to every single term inside those parentheses. So 2 times x squared is going to be 2x squared. 2 times negative 4 is negative 8. And like I said earlier, I can drop the parentheses, so this will all stay the same. Okay. Now let's find any like terms. Let's look for the highest exponent. The highest exponent that I see is a 2. So I'm going to do 2x squared and then negative 5x squared first. Those combine to make negative 3x squared. And then 3x is actually all by itself. There are no like terms, so it's going to be plus 3x. And then I see that I have one more set, so the next exponent would just be no exponent. So negative 8 plus 37 is going to be, I think, positive 29, I believe. Let's double check that with the calculator. Yes, 29. So that would be my final expression simplified. No like terms here. All right, and let's classify this. This would be a second degree because the highest exponent is a 2, not a second. And then the amount of terms is a trinomial because there's only 3. Whoops. All right, we have 3 more examples left. So number 4, we have negative 3x times x plus 2. And I think I'm going to move this down actually to the next line. X plus 2, and then we have plus 2x times x squared plus x plus 5. Okay. So here, like earlier, we couldn't just drop the parentheses. We actually have to distribute this time. So Negative 3x times x is going to be negative 3x squared. Remember, x times x is x squared, not 2x. Negative 3x times 2 is going to be negative 6x. All right. Now we have 2x times x squared, which is going to be a positive 2x cubed, because x times x squared is x cubed. Remember, you add those exponents when you're multiplying same bases. 2x times x is going to be 2x squared. And then 2x times 5 is going to be 10x. And now I'm going to look for my highest exponent, and my highest exponent is 2x cubed. No like terms with that, so I'm going to go ahead and just write that down. Okay, the next one I see is negative 3x squared and positive 2x squared, right? So you want to start the next highest exponent. That's going to be negative x. Oh, sorry, x squared, my bad. And then the next highest exponent I see is just an exponent of 1, so that's going to be negative 6x plus 10x. So those are like terms, and that's going to give me positive 4x. And that would be my simplified expression. And this would be a third degree trinomial. Number 5, so we only have 2 more left. All right, the next one we're going to do is negative 5x squared times x squared plus 2x minus 7 plus 2x squared times x squared plus 7x minus 12. So we only have 2 problems left. So we can make it. All right, again, we're going to have to distribute here. Negative 5x squared times x squared. This is going to be negative 5x to the 4th, because 2 plus 2 is 4. Negative 5 times 2x is going to be negative 10x cubed. So negative 5 times 2 is negative 10. And then x squared times x is going to be x cubed, because you have 3 x's being multiplied. And then I have negative x squared times negative 7. That's going to be positive 35x squared. Next over here, we have 2x squared times x squared. That's going to be positive 2x to the 4th. Oops. Move this that way. Okay. And then we have 2x squared times 7x, and that's going to be 14x to the 3rd, because x squared times x is x cubed. 2x squared times negative 12 is going to be negative 24x squared. All right, let's look for some like terms. Some like terms that I see, I want to start with the highest exponent. So the highest exponent I see is a 4. So this one and then this one. So negative 5x to the 4th plus 2x to the 4th is negative 3x to the 4th. Pink. The next highest exponent is a 3, so negative 10x cubed plus 14x cubed is going to be plus 4x cubed, because negative 10 plus 14 is 4. And then lastly, I have 35x squared minus 24x squared. That's going to be plus 11x squared. And let me double check that with a calculator. Yep, looks good. All right, so I'm going to go ahead and box my final expression. And this is going to be a 4th degree trinomial. All right, we're on to our last one. So, number 6. X minus 3x squared plus 5 plus 7 minus x plus x squared. Let's see what else. I'm going to add one more. Plus 3 plus 7x squared. Let's just do that. All right, so this is our last example. Now, what's different about this? Well, the thing that's different about this is that I have 3 polynomials being added together. I have a trinomial plus a trinomial plus a binomial. However, I don't really have to distribute anything because in front of every single parentheses, I just have a 1. So there is no distributing really necessary. So I can just actually copy down everything as is. All right. Okay, so this is what I have now. And now I'm going to look for some like terms. I'm going to start with the highest exponent, which is a 2 here. I have negative 3x squared. I feel like this orange is really hard to see. Let me change this because it's really hard for me to see actually on here. Green. Green. Okay, I'm going to move it. Oh, I don't want that. Put that back. Okay. Changing that so I can see a little bit better. All right, so I see negative 3x squared. I see a positive x squared, and then I also see a 7x squared. So here I have 3 like terms. So negative 3 plus 1 is negative 2, and then negative 2 plus 7 is positive 5x squared. So that's going to be 5x squared there. Let's do blue next. Okay, the next highest exponent I see is an x, is an x minus x. Well, I have x and I take away x, what do I have left? 0x, right? So, for example, x minus x, 1x minus 1x is going to be 0x, right? Not x. So the common answer I get is when I get x minus x, does that equal x? Does 1 minus 1 equal 1? No. 1 minus 1 is 0, so this is just going to be a 0 here. So what does that mean? It means they cancel each other out, so they actually aren't even existing anymore. So they're gone. So x minus x equals 0. Just go ahead and write that a note for yourself. Now I'm not going to write 0 here, but if you really want to write 0, you can, but we don't really need it. All right, and then I have 5 plus 7 plus 3. So 5 plus 7 is 12, and 12 plus 3 is 15. So that's going to be my next term. So this is my final expression. And this would be a second degree binomial. All right. That is it for adding polynomials. If you have any questions, please feel free to ask.